Okay, this is a review of the first 5 laws. We didn't go over the 6th law yet, but these are the first 5 laws in action and how to solve these questions using what we would call exponent laws. So the first one gives us the product of two numbers to an exponent. And what the law says is you can take your 4 and you can divide it between your two numbers evenly. So instead of saying 5 times 3 to the power of 4, you can say 5 to the 4 times 3 to the 4, which is 5 times 5 times 5 times 5, which is 25 times 25, which I think is 625 times 81, I think. If I grab my calculator and say, what is 625 times 81? It says 50,625. Is that correct? Did anyone else get that answer? Did I get that right? Yes? Perfect. And the law in question, just remember, if you have an exponent to two numbers that are being multiplied in the brackets, you can give that exponent to both numbers, simplify them into standard form, and multiply them together. In the second question, we're actually using law number 3. It's a power to an exponent. And before I show you what the law says, remember 3 cubed cubed means you take that 3 cubed and you multiply it by itself, not once, not twice, but 3 times, which should be, using law 1, 3 to the 9. But that's not how we're actually going to solve it. The rule is when you have a power to an exponent, you keep your base and you multiply your exponents together to give you 3 to the exponent of 9. Grab your calculator, ask it, what is 3 to the exponent of 9? And it will tell you 19,683. Remember, the work you need to show, though, is right here. That's the step you need to show that you understand what you do when you have a power to another exponent. You keep the base and multiply the exponents. Your third question gives you the multiplication of powers that have the same. So the law 1, it says keep the base and add your exponents to give you an answer of 5 to the 5, which should be 3,025, I think, or something like that. 5 to the exponent of 5 equals 3,125. But again, the law in action is keep your base and add your exponents to simplify it to a single power of 5 to the 5. In our third example, we have the division of two numbers to an exponent outside the brackets. And our law states we can disperse this exponent onto both parts of the quotient. So we can have 1 cubed divided by 2 cubed, which will be 1 divided by 8, which will be 0.125. Alternatively, and interestingly enough, we could have rewritten this question a different way. We could have written it like this. 1 divided by 2 cubed. It's the exact same question. The black question and the red question are the same thing. Do you all see that? And in the event that we did that, we could have 1 to the exponent of 3 divided by 2 to the exponent of 3. 1 to the exponent of 3 is 1, because 1 times 1 times 1 is 3, is 1, sorry. And 2 times 2 times 2 is 8. And 1/8 is a decimal, is 0.125. So you need to be able to see them both ways. Both are the same. This yellow highlighted thing here is the exact same thing as this green highlighted part right here. They're the exact same question, just different formats. And the fifth question is division of two powers that have the same base. Your law states keep your base, and subtract your exponents. Okay, we'll see you guys all next class, and you get 3 to the exponent of 9. And our last question, we're going to keep our base and add our exponents, or 2 to the 8 divided by 2 to the squared, which we're now going to keep our base and subtract our exponents to give us 2 to the power of 6 squared, which we're then going to keep once we're using this as law number 3, keep the base and multiply our exponents. We're going to get 2 to the 12, which is equal to, I think, 4,096.